Hi everyone, welcome back to week 3 learning materials of manufacturing process. Today we are going to discuss about various metal casting processes. Learning outcome is explain the process principles associated with casting and foundry operation and assess their process dynamics and performance. Outline of this chapter: we are going to study about sand casting, expandable mold casting processes, permanent mold casting process, foundry practice, metals for casting, and some of the product design considerations. Expandable mold casting process. Mold is sacrificed to remove part. This already we explained in our previous lecture that expandable mold casting process means we are using the mold only for once. After making the mold or after casting process, we have to break the mold and then take out the product. That means the mold is sacrificed to remove the part. Only once we can use. Advantage of expandable mold process is more complicated shapes can be castable. Disadvantage is production rates often limited by time to make mold rather than casting itself. Production rate and time is very critical in expandable mold casting process. Now, permanent mold casting process means mold is made up of a metal that can be used to make many castings. That means reusable type. And the mold is not made up of sand, but it is made up of metal. Expandable mold casting process, a mold is made up of sand, whereas in permanent mold casting process, it is made up of a metal. Disadvantages: the geometry is limited by need to open mold. That means very simple geometries can be casted. So complicated shapes cannot be casted using a permanent mold casting process. Now, sand casting, already we discussed before, is the most widely used casting method where we use sand and clay. Clay is used as the binder. Nearly all alloys can be sand casted, including metals with the high melting points such as steel, nickel, and titanium. This is the beauty of sand casting. High melting temperature alloys such as steel, nickel, and titanium can be casted using this. Casting ranges in size from small to very large, and the production quantities can be from 1 or 2 millions per annum. This is basically a compressor frame. This is produced by compressor frame, which is produced by a sand casting process. Steps in sand casting, we already discussed about sand casting process before. So we have to make a pattern first. Pattern will have the same shape of the product to be produced. So pattern materials normally wood, metal, or plastic. And this pattern is used for making a mold. Mold or a shape of the product is produced with the help of pattern and sand. Sand is compacted around the pattern to produce a mold. After producing the mold, a core is inserted. Core means any internal parts like holes or hollow sections, we have to use core. Then so we prepared a mold. Once we prepare a mold with the help of pattern, which is the shape of the product to be produced, and around the pattern we compact with sand, and then we attach core at the end. So we produce mold using this process. After producing mold, we pour molten metal to the egg. This molten metal will get solidified, and after solidification and cooling, we remove after solidification and cooling, we produce a casting. But how to take out the casting is we have to remove the sand mold, clean and inspection to get a final finished product. What type of patterns? As I explained before, patterns can be wood, common material, metal, which is more expensive but lasts much longer, plastic, compromise between wood and metal. Normally wood is used. Now you can see here patterns can be different types. A solid pattern, completely solid. Split pattern, that means half, it is split or divided into two, split into two. Then we have a match plate pattern. That means the pattern is connected with a plate so that it can be used for other casting processes. Then cope and drag pattern. That means there are two parts. One part will be connected with a riser and it will be in the cope. And the second half, first half will be connected with the riser and fixed in the cope. Second part will be in the drag. So there are two halves connected with the a riser. This is also very common. So these are the type of patterns generally we use. Core. Core is actually, this is the core. Core is inserted into the mold cavity just before pouring, prior to the pouring. Why we need a core is to produce holes, to produce hollow sections, etc. It can be of any shape like square, rectangular, circular, etc. So this internal parts can be produced by core. Sometimes cores are fixed with the help of chaplets. Chaplets are just used to fix the core inside the mold. Otherwise, whenever molten metal enters, it can move the core out of the position. Hence, they are fixed with the help of chaplet. While melting, the chaplets also will get, when we pour molten metal, chaplets also will get melted with the molten metal. So this is all about core, to produce internal parts. Now, which material is generally used for sand casting purpose? Normally, silicon dioxide, silica, sand is used mixed with clay, which is a natural binder. So a small grain size of sand means your finish, the surface finishing will be more. If the grain size is larger, then the surface finish will be less. 90% sand mixed with 7% clay and 3% water. This is the mixing ratio. Sometimes we go for organic resins like phenolic resins or inorganic binders like sodium silicate and phosphate. Now, buoyancy in sand casting process. So during pouring, buoyancy of the molten metal tends to displace. There will be a force which tends to displace core, which can cause the casting to be defective. So the force which tries or tends to lift the core is equal to the weight of the displaced liquid minus the weight of the core itself. So how much buoyancy force acting in a core? So we fix a core in here. Whenever we pour molten metal to the core, to the cavity, what happens? Molten metal comes and push the core. So that's why there is a buoyancy force acting. That buoyancy force is equal to weight of the mold, weight of the liquid molten metal minus weight of the core. So this is how we calculate the buoyancy force. Then other expendable mold casting processes. Other expendable mold casting processes are shell molding, expanded polystyrene process, investment casting. These are the other types of expendable mold casting process. As I explained before, expendable means we have to break the mold and take out the part. Only once we can use the mold, it is not reusable. A very common expendable type is sand casting. Already we discussed about sand casting. What are the other methods? Other methods are shell molding, expanded polystyrene, and investment. In shell molding, as you could see here, mold is a thin shell. This you can see a thin shell of sand. This sand is held together by a binder, a resin binder. So there is a thin shell of sand bound together by a binder, resin binder. So there is a pattern here. So in the steps, what we do, this is the pattern, this is the shape to be produced. So we fix this pattern, it is heated, okay. So the pattern is heated and placed over the box containing sand mixed with the thermosetting resin. So sand mixed with the resin here. So the pattern, this is the product to be produced, this is heated and placed over the shell. This is first step. Second step, what we do, a box is inverted. Look at that, the box is inverted upside down so that sand and resin fall onto the mold. So sand and resin will fall onto the mold, onto the hot pattern, which causes a layer of mixture partially cure on the surface to form a hard shell. So when we inverted, what happened? The sand plus resin mixture, binder mixture will fall onto the hot pattern, and this will get attached with the pattern. This is step 2. Step 3, box is again positioned back to its normal condition. So what happened? Again, box is repositioned. Whenever we reposition the box, what happens? The loose particles of sand and binder will drop away, and only the particles of sand and binder attached to the hot pattern, it will remains there. Then 4, so see here, this layer will have the same shape of the product to be produced. Now step 4, the sand shell is heated in the oven. There is an oven, so we heat them in the oven for several minutes to complete curing. After heating, this is basically for it's a curing process, so that we can increase or improve the strength of the mold. Otherwise, the mold will have less strength. So, in order to improve the strength, we heat it in an oven, and then after taking out, so we strip it from we can strip the mold and the pattern, and then we get a perfect shape. And then when we connect them together, these shapes, we get a mold, and then we can pour molten metal into it and can produce a part. This is all about shell molding. Now, advantages and disadvantages of shell molding are: advantages, smoother cavity surface permit easier flow of molten because we are using sand, hence we can have a surface finish, better surface finish. Good accuracy can be produced. Machining, less machining is required. Mold collapsibility minimize cracks in casting. Cracks can be reduced. It can be mechanized for mass production. Disadvantages are more expensive metal pattern. We are using a metal pattern for it. They are expensive. Difficulty to justify it for small quantities because it is expensive whenever we go for small quantities. Now we come to expanded polystyrene process. In expanded polystyrene process, we use as a mold or sand packed around a polystyrene foam. This, see here, the pattern is made up of polystyrene foam. The pattern is made up of a foam which vaporizes when molten metal is poured into it. So polystyrene foam pattern includes what are the things attached with the foam: sprue, risers, gating. All parts of a casting system are included with the polystyrene foam. You can see here cup and sprue, then foam pattern. This is the pattern. So after making it, we have to spray refractory compound, etc. So what are the steps involved? So we are using a foam as the pattern. So pattern of polystyrene is coated. First step, this is the pattern. We made a polystyrene. We made a shape of the product to be produced with the help of polystyrene foam, and after that we spray refractory compound at temperature. Then we, after making the foam pattern, this is the shape to be produced. Then it is attached with the riser, and which is attached with the sprue, etc. Then foam pattern is placed in the box and compacted with sand. After compacting with sand, what we do? We pour molten metal into it. The foam will vaporize. The foam, because of the high temperature of the molten metal, foam will vaporize and it will escape. So you can find only a cavity which is having the same shape of the foam pattern. So to this cavity, when we pour molten metal, we can produce a product. So what are the advantages and disadvantages of this? Advantages of polystyrene pattern. Pattern need not to be removed. Directly pour molten metal, it will vaporize. Simplifies the speed of mold making because two mold halves are not required. Only one solid mold is pattern is required. Only one half is required. Two halves are not required. Disadvantages: a new pattern is always required. Every product, a new pattern you have to make. Economic justification is dependent on cost of producing pattern. The cost of producing the pattern, the complexity of the pattern, the cost is directly related to the cost of the product to be produced. Mass production can be applied in such cases wherever we go for automobile engine parts. Now we come to investment casting. Investment casting or loss to wax process, because wax will melt in this process. So here patterns are made up of wax and is coated with the refractory material to withstand the temperature. It is a precision casting process. It can accuracy is more. It can produce castings of high accuracy and intricate detail. One, we produce wax are produced. Then wax patterns are produced. After producing wax patterns, for example, this is the product, this is the shape of the product to be produced. So we produce a pattern which is having the shape of the product, and with the help of wax, we produce the shape with the help of, or pattern with the help of wax. Then we connect the parts, several parts, with the help of a sprue. It looks like a tree then. Several patterns are attached to a sprue, common sprue here, and then several wax patterns are attached. Then this pattern is coated with the refractory material. This is temperature to withstand the temperature. Now 4, the full mold is formed by covering the coated tree and with sufficient refractory material to make it rigid. So the pattern tree is coated with thin layer of refractory material, step 3, and then for the full mold is formed by covering the coated tree with sufficient refractory material to make it rigid. You can see here, this is refractory material already attached with it. And then 5, the mold held in the mold is keep it in inverted position and heated to melt the wax and permit to drip it out of the cavity. You can see here, this we will keep it upside down or keep it inverted position, then heat it. When we heat it, I discussed, we produced the mold with the help of wax. When we heat it, wax will melt and it will drip out of the cavity. The mold is preheated, so you will have only the mold here, which is like a refractory material. Then it is heated. Mold is preheated to high temperature to increase its strength, etc. Then molten metal is poured into it to get the required shape. You can produce several products using this. You can see here on one of the compressor stator. This is the compressor stator with around more than 100 separate airfoils made by investment casting. So you can see here how complicated and how intricate parts can be produced by investment casting. This is the advantage of investment casting. So parts of great complexity and intricacy can be produced. The advantage of this process. A very close dimensional accuracy can be produced. Wax can be wax can be melted and used again. Additional machining is not normally required. Disadvantages: many process steps are involved. As I explained, there are around 7 processes involved in this, so it takes time. Relatively expensive process comparing with other processes. These are all about module 2, week 1 video. Thank you very much for listening. Thank you.